Again, one of the things that often causes confusion here is the addition of x's and y's together. Okay, so if we look at this first fractions numerator, we recognize a division problem, so we're going to invert multiply. We can factor in the same steps. So we're looking at the difference of two squares here. We have a base x squared, and then what base do we square to get 4y squared? 2y. So we can factor this into the sum and difference of those terms. So x and 2y. Sum times the difference. So there's the factors of our numerator. The denominator is also the difference of squares. So when you look to factor this as well, it factors into the same sum and difference of those terms, x and 3. Take the sum and the difference. And now we're going to convert this into a multiplication problem. So we have to invert our fraction. So the x from the denominator gets moved up to the numerator. And then in this form, again, the y's can be deceiving. Hey, they really are. You can just disregard them and plug them back in. When you're factoring, this is a trinomial factor, or a trinomial that has binomial factors. So our first, when we reverse FOIL, first terms have to have a product of x squared, so the only possibilities are x and x. Our last terms of the binomial factors have to have a product of 2y squared. So again, when you test these, you only have to test a couple cases here, and really just the one. You know that their product is positive, their sum is negative, so both of these will be negative signs. And so the only two factors that will give you 2y squared are y and 2y. Okay, so those would be your factors. You can now go through and cancel any common factors. So the x plus 2y is no, x minus 2y is yes. There's nothing else that can be canceled in that. And so now when you multiply across the top, you have a monomial factor x, a binomial factor x plus 2y. In the denominator, you have three trinomial factors. Doesn't matter the order that you write them. They're all first degrees. Okay, what I do want you to keep in mind is do not expand these out. When you're writing your answers for any of these, leave them in factored form. Okay, there's no reason to expand it or write it as a polynomial. And when you guys start to graph all of these, which will happen next year, the factored form is going to be what gives you the information. The numerators factors will be your zeros. The denominators, the factors in the denominator will be your asymptotes or your undefined values. Okay. All right, so the last part of this is to identify any domain restrictions. Okay, so you look through your the process. We had a canceled factor. So what do we know x can't be here? 2y. Okay, now, this is where that exception comes in because we inverted and multiplied. This whole original fraction, which is in factored form here, there's not a single factor of those that can equal 0. So the x minus y, we're fine. That's shown in the denominator. The x minus 2y, we've already accounted for. But what about this x? When you look back at this original form, what do you know x could not be? So you have to account for that in your domain restrictions as well. Okay, so double check all the factors of the number you're dividing by, both numerator and denominator. They can never equal 0. All right, I will release your